Hello, my name is Nicole Stevens. I'd like to share insights from the assessment of a randomized clinical trial, focusing on how evaluation designs, methods, and data affected the validity of the outcomes. The trial we'll discuss is entitled Effect of Wearable Technology Combined with Lifestyle Intervention on Long-Term Weight Loss by Jakicic and colleagues, published in 2016. This program tested whether an intervention including behavior modification plus wearable technology helped participants lose more weight than those with standard behavioral intervention alone. The standard behavior modification included group meetings discussing educational material, telephone interviews, motivational text messaging, categorical diet and exercise regimens based on BMI at baseline, and diaries to self-monitor habits. Participants in the experimental group used standard behavior modification plus a wearable sensor that tracked energy expenditure and physical activity, so it provided the participant with real-time feedback. Participants ages 18 to 35 were recruited using social media and mass mailings. 471 participants were randomized to these treatments, and the groups were very similar in terms of demographics, including things like age, gender, alcohol, and tobacco use, BMI at baseline, education, employment status, and income. This experimental randomized design with mixed model methods included a two-group prospective cohort. According to ISL 2022, this design is, quote, an important feature for programs with a potentially long time lag between intervention and evidence of outcome, end quote, such as long-term weight loss, which this study was intended to measure. Participants were measured at baseline and 6-month intervals over 24 months for physical parameters such as weight, body composition, and BMI, activity parameters such as sedentary time and cardiorespiratory status, and safety parameters such as depressive symptoms, high blood pressure, and too rapid weight loss. In most measures, the control group, the behavior intervention only, significantly outperformed the experimental group, the behavior plus wearable technology, in the study outcomes. The authors of the paper point out that both groups lost a statistically significant amount of weight compared to baseline, but the groups differed in their outcomes. The graph here shows weight loss for both groups, and the asterisk represents statistical significance between the two groups, with a p-value less than 0.05. Both groups lost weight quickly, then regained some of the weight back by the end of the study, but the control group was more successful at keeping the weight off compared to the experimental group. This was somewhat of a surprising conclusion, but I believe well-founded based on the validity of design, methods, data, and interpretation by these researchers. For this exercise, the trial was ranked on a series of assessment components with multiple subcomponents given a score of 1 to 5, where 1 represents low threats to validity and 5 represents serious threats to validity. Mean scores will be presented for each assessment component. Lower scores and fewer perceived threats in each component area suggest aspects of higher validity. Assessment component 1, objectivity and confirmability. Are the conclusions drawn from the available evidence, and is the research relatively free of researcher bias? Researchers in this paper mentioned potential biases in participants who dropped out, who may be different from those who stayed in the study. They also mentioned that study staff knew they were taking assessment measurements in a weight loss trial, which may have biased those measurements. However, the study protocol described painstaking attention to detail in training staff to take measurements consistently. Data appear to be generated objectively with attempts to minimize bias. This part of the assessment was given a score of 1, with 0 perceived threats to validity. Assessment component 2, internal design validity. Are the findings credible to the people studied and to the readers, and do we have an authentic portrait of what is being studied? In this aspect, some threats to validity appear. Testing bias could be a big factor. The act of being measured for a weight loss trial may affect the participants' behavior responses. Recall bias is also a big player, since participants are asked to recall dietary choices throughout the study. Since this was a 2-year study, maturation likely produced natural changes in physical development, knowledge, behavior, and experience, which could introduce bias into the results. Selection bias could also be present, since participants self-selected to join the program, and we don't know if there are fundamental differences between participants and non-participants. Finally, the authors did not indicate whether the wearable technology had been validated for use in clinical research. There could be validity and reliability issues with their main experimental construct. Still, the authors did a reasonable job trying to control these and other sources of bias. This section was given a score of 1.5 with 5 possible threats to validity. Assessment component 3, threats to statistical conclusion validity. We talk about reasons why inferences about statistical association or covariation between two variables may be incorrect. Here, the researchers did a very good job minimizing threats to statistical validity with a score of 1.4. The two main perceived threats here include the possibility of external events influencing the outcomes, since this is a long study, and extrapolation from missing data. Researchers mentioned that they used the Monte Carlo Markov chain imputation statistical method to extrapolate missing data based on other responses from the same participant at different time points. While this makes the dataset more complete, it could introduce bias and inaccuracy into the findings. Assessment component 4, construct validity. These are reasons why inferences about the constructs used to define implementation processes, outputs, outcomes, and impacts may be incorrect. This is another area where a number of threats could affect researchers' conclusions. Participants' knowledge or interpretation of the project may affect their behavior. Their awareness of this trial as a weight loss intervention could influence choices and expectations of outcome. Novelty of wearables is potentially an issue. In this case, it didn't produce a positive effect compared to the control, but it could have altered behavior by encouraging participants to rely heavily on expected benefits of a wearable. The control group may have experienced compensatory effects and rivalry, perhaps feeling pressure to perform without the wearable device and achieve greater results on their own. On this component, the paper scored 1.6 with 4 potential threats to validity. Despite possible challenges, researchers did a good job generally, thinking through implementation and evaluation processes and drawing inferences and conclusions from the data. Assessment component 5, external validity. Do the conclusions fit other contexts, and how widely can they be generalized? Authors acknowledge that these results aren't generalizable to a wider audience. The young adult age range is very narrow here and is different than teens or older adults. Additionally, these results may not hold across different racial, ethnic, or socioeconomic populations. There are likely to be seasonal variations in exercise patterns and variability across stages of life. The findings are not entirely congruent with other trials that did show added benefit from wearable devices, but the authors at least offered additional hypotheses to test about why that is. The assessment component here ranked 1.6 with at least 3 perceived threats to validity. Finally, assessment component 6, utilization. How useful were the findings to clients, researchers, and the communities studied? In their publication, the authors did not mention plans to reach stakeholders with means other than the publication itself. This may not be accessible to the general population. A recommendation in this area might be to produce a layperson-friendly output, like an infographic, that could be released to trial participants, healthcare providers in the weight loss sector, and the general population. For this component, a score of 1.3 was assigned with 1 threat to validity. In conclusion, this randomized controlled trial is a great example of a research study that is well-controlled, well-designed, and comes to a conclusion that is believable based on the data. A large sample size and quality control checks at every stage contribute to the outcome. The fact that this trial is published in the journal with the second highest impact factor in all of scientific literature also speaks to its quality. It's interesting that although the study concluded it did not have enough evidence to support the hypothesis, it was compelling enough for publication in the Journal of the American Medical Association. The few ways the study could be improved are mostly around additional methods to minimize bias, such as including measurement tools for seasonal and maturation variability, masking assessment staff about the goals of the program, providing validation information about the wearable technology. The utilization of the study as an infographic or other accessible format would also improve dissemination to a wider audience. Overall, this is an excellent study with impressive design and execution. In fact, my team and I, in our clinical research studies, plan to implement some of these designs and major constructs. Here are the references we discussed in this presentation. Thank you so much for your time and attention today.